Okay, well, I guess we'll get started. It looks like we have everything in line. Thanks and welcome to everyone for joining. Hopefully you're able to hop on this webinar without any difficulties. My name is Nick Sondholm. I'm the co-chair of the New York City Future Leaders Committee of CTBUH and a project engineer at Thornton Thomas Eddy. I have the pleasure to introduce this webinar. This is our third webinar through New York during the pandemic. Today we're going to take a look at Greenpoint Landing Block D with our partners OMA and DeSimone. And before I hand it over to OMA and DeSimone, I'm going to give a brief overview introduction to CTBUH and New York Chapter specifically and what our initiatives are and what we try and achieve. So CTBUH has a pretty global presence with three offices, in Chicago, Shanghai, and Venice, with kind of a global affiliate all over the world, New York local chapter being one of them. The membership of CTBUH by profession, is developer engineering, architecture, and then all the other sub-consultants within the built environment. And by region, predominantly North America, Asia, and Europe, but there are other growing regions that are showing representation as well, namely Africa, which after the past few years and hopefully in the future will sustain further development and be able to contribute a little bit more to our group. And so some of the objectives that the New York City chapter specifically adheres to is to connect the diverse design disciplines professionals in New York City, act as an incubator for young professionals and next generation of CTBUH leaders, foster this interdisciplinary collaboration, which is on show today, and organize local events such as one of these to kind of adhere to all the three objectives above. And so if you aren't a member, please do reach out. And if you want to be a member, please do reach out to either I or anyone that's affiliated with the group. Some of the benefits of being a member include these events like these, but also books and other working groups, resource centers, journals, and other technical information that's made available through the membership portal. And just to give a brief overview of past events in the past year or so, this isn't an exhaustive list by any means, but previously we did a global walking tour, which was a good combination of, or a good group of about 30, 40 people walking around New York streets in the middle of dead summer. It was a great experience to kind of showcase some of the architectural landmarks around the city and talk about their construction and design. We also had a co-living event, which was well attended. A New York earthquake ready event discussing if New York is ready for a earthquake event that's might be coming in the near future. As well as one of our larger events was the 10th World Congress in conjunction with the headquarters office in Chicago. New York City hosted a regional conference which attracted 100+ attendees with 2 days of programming, including building tours and presentations somewhat similar to this. And during the pandemic, we've had 2 webinars, one being takeaways from work from home culture, as well as future of construction industry, highlighting the different technologies that are helping and pushing forward the industry at large. And hopefully we'll be doing more of these webinars until we have a chance to be back together. So these are some of the images, kind of give you a taste of some of the previous events, a lot of building tours and exposure. On the left here is a partnership with some of our RWI friends, showcasing the Tune Mast Damper on the top of 111 West 57th Street. We also toured One Vanderbilt and have given many technical presentations, this one being at our partners FX Collaborative's office. Some future events, we would like to continue with technical webinars. We're also, we also have robotics and construction on the burner as well. Going to Mars with AI Space Factory, Foster Plus, and many others who are pushing forward this initiative, which will definitely be a quite interesting topic. Sustainability and new energy is always something that's on our minds and something we try and push forward. With Oklahoma 97, things are, things are definitely changing in how we design buildings and how we have to retrofit buildings for the new energy regulations, as well as some RWDI events and educational committee initiatives as well. So without further ado, I'd like to just introduce our panelists for the day and then hand it over to them to give their brief presentations. So from OMA, we have Jason Long and Chris Yoon. Jason is a partner at OMA based in the New York office. Since joining the firm in 2003, Jason has brought a research-driven interdisciplinary approach to a wide range of OMA projects internationally. From concept to completion, he served as a project manager for a new national museum in Quebec City and the Fane Forum, if I'm pronouncing that correct, a multi-purpose venue in Miami. Currently, he's focused on a number of adaptive reuse projects, including transformation of a post office warehouse in downtown Houston into a mixed-use hub, a historic parking garage in New York City into a synagogue, and a renovation project in University of Toronto for a university administrative center. His portfolio extends to residential development in California and New York, including the Avery in San Francisco, and most recently, the 2 towers for Greenpoint Landing, which we'll be talking about today. Jason holds a Bachelor of Arts in Philosophy from Bazaar College and a Master's of Architecture from Harvard GSD, and he also currently teaches at Cornell University School of Architecture. Chris Yoon is an associate at OMA's New York office. She has extensive experience working on a variety of architectural typologies and community-oriented design. She is currently serving as project manager on the Greenpoint Landing Block D development and is responsible for overseeing OMA's role as a design architect for this large-scale development. She has extensive experience working on New York residential developments, ranging from luxury townhomes to large multifamily condo and rental developments. Prior to moving to New York, Chris is working on building envelope consultant in San Francisco, providing a range of services from structural engineering, facade, and envelope consultation, and forensics analysis. She holds a Bachelor's of Science in Architectural Engineering from UT Austin, and is a registered architect in New York State and a LEED accredited professional. And then from our DeSimone team, we have Luis Ramirez, who is a principal in the DeSimone's New York office. In his time at DeSimone, Mr. Ramirez has amassed a diverse portfolio of projects, including high-rise structures, office towers, mixed-use developments, resort properties, and healthcare facilities, both internationally and domestic. So quite an experienced individual. He is currently designing OMA's Greenpoint Landing Site D, along with Allan, a 950,000 residential development. The building is highlighted by the westernmost 40-story tower, which we'll see here in a bit, which steps out 3 times along its height. That results in a 50-foot cantilever of the uppermost massing relative to its base. Mr. Ramirez is a registered professional engineer in the state of New York, and he received his bachelor's and master's of science in civil engineering from Manhattan College. And finally, Allan Ho is a senior project manager in DeSimone's New York office. He has worked in a wide range of construction projects as well in New York areas, including residential, commercial, retail, and mixed-use projects for both new construction and renovations to existing structures. Mr. Ho's recent work includes the Empire Outlets project in Staten Island, a 900,000 square foot retail outlet center with hotel and parking garage, the South Bronx redevelopment project, and many others. Mr. Ho received his Bachelor of Science degree and his Master's of Science degree in engineering from the Cooper Union for the advancement of science and art. So without further ado, I'm going to hand it over to Chris to begin the discussion.
Hi, everyone. Let me just pull up my screen.
Sure. Looks great.
All right, so I'm going to actually let Jason start off the presentation. But here you can see a list of all of the people that have been involved on the sort of design team side through this process, which started in about 2017. But with that, I'll hand it to Jason. You're muted, Jason.
Good start already. I really want to thank everyone that's been involved in this project. Of course, we're the design architect, but we're also working with Beyer Blunder Bell as executive architect, and Marmel Ratzinger doing the interior design and the landscape on the kind of terraces that you'll see as part of the design. And of course, given the kind of structural ambitions of the buildings, DeSimone has been really critical, and we're really excited to be working with them on the project and when able to present it to you with them today. I was going to say just a few words about our office at the beginning. We're an international partnership with 9 partners, of course, founded by Rem Koolhaas, a Dutch architect, and now working kind of all over the globe. We have 3 offices in Rotterdam, our largest office, and also there's an office in Hong Kong where we oversee most of the work in Asia. And then, of course, our office here in New York, where we have about 70 architects working under 2 partners, myself and Shoei Shigematsu. I think that our work is, we hope at least, always responding in very specific ways to very specific conditions and trying to utilize that specificity to bring out something unique in each case, not necessarily striving for any particular outcome at the beginning, but rather trying to let the particular circumstances take us someplace, in each case, new. We're doing kind of an array of different things, and I think one thing that does unite them all is that we're very interested in how a building fits in with the city around it, and both in the way that its design fits in, but also in the way that it makes a place that welcomes people to it. Both for public projects and for commercial projects. We're well known maybe for doing cultural buildings, from museums to cultural centers, to kind of here in New York, we recently helped Sotheby's renovate their galleries, for example, and we're also working on the expansion of the Albright Knox Gallery in Buffalo. We're also doing a lot of different mixed-use projects and commercial projects, really all over the country, but of course also outside of it. And office projects, for example, the Axel Springer project in Berlin, which is soon to be opened, actually, and also a building we're working on in Boston in the Seaport District. We're also doing retail buildings, from interior retail spaces to new department stores of varying scales. And maybe more surprisingly, we're engaged in a number of projects that are actually really dedicated to providing public spaces. For example, the 11th Street Bridge Park in Washington, D.C. is a new bridge that will be, like the High Line, provide a public park on former infrastructure here, where we're using bridge piers to build a new pedestrian and park connector between the east and west sides of the Anacostia River. And more to the point for this project, we're also doing quite a number of residential projects. Residential is, of course, a very specific type of building to do, especially within the context, I think, of the United States, where the ambitions of developers are really there, but at the same time, of course, we need to work within constraints of both constructability and market conditions. And that brings me to this project, which we think, we hope is a good response. And now I'll hand it over to Louise to talk a little bit about DeSimone.
Thank you, Jason. Can everyone hear me? Yeah. You know, DeSimone is a multidisciplinary engineering firm with offices throughout the U.S., in South America, and in the Middle East. And similar to OMA, we work on a wide variety of projects, different typologies. We've had the good fortune of working with Jason and his team on a number of projects on the Faena Forum, I'll try to get through the slides. But so here you can kind of see the different types of services that we provide and how each one of these informs a lot of the decisions that we make on a specific discipline in the design phase. And likewise, during construction, with our inspections, forensics, and risk management, a lot of the things that we see on the design side inform a lot of the evaluations that we perform, and vice versa. What we see during construction informs a lot of the innovation that we do on the design side. So with that, we'll kick it back to Christine. Chris.
Actually, I'm going to let Jason keep, he's going to introduce the project a little bit. We're finally getting to Greenpoint Landing Block. Everyone is here, so maybe we'll get started.
Yeah, sorry for the lengthy introduction, but anyway, okay, so this project is obviously at the tip of Brooklyn, at the northern end of Greenpoint. Here you can see, so just below Newtown Creek is the neighborhood Greenpoint, just north of Williamsburg, and of course to the on the east side of the East River. This whole waterfront of Brooklyn and also the Long Island City has of course been transformed over the last decade or a little longer by a wave of residential development seeking to provide new housing along the waterfront. I'm sure you're familiar with most of this, but the developments in Long Island City, maybe the first of these, the development at North 4th in Williamsburg, a series of 4 towers, and then of course more recently the buildings that are going up now and Domino from Two Trees. So Greenpoint itself has a slightly different history than some parts of Brooklyn, but similar in some ways. Of course, there's a long history of industrial production that happened here in Greenpoint, especially at the water's edge. There was shipbuilding, printing, pottery, glassworks. If any of you have ever been to the Glassery, the restaurant that's kind of almost at Newtown Creek, that's of course there because of, was in fact a place where glass was made. And a lot of the industrial buildings form what maybe many people think of as the character of Greenpoint, with industrial spaces being repurposed for different uses, for spaces of new kinds of production, but also spaces for restaurants and even residential. But when you look at the fabric of the city, actually, of the neighborhood, actually a lot of it is not necessarily industrial buildings, but rather 3-story or 4-story multifamily townhouses that run along Franklin and Manhattan and the streets that connect them. In a sense, the neighborhood is it's a contrast to Manhattan, dominated by high-rises, and then Greenpoint, until now, primarily dominated by low-rise development. But Greenpoint itself also has this similar contrast between an industrial waterfront and a low-rise neighborhood that historically had very little access to that waterfront, given the large sites and industrial uses along the East River and along Newtown Creek. And within that, this is kind of the larger development that's being developed by Park Tower Group and Brookfield, called Greenpoint Landing. So there was a master plan done originally in conjunction with Handel, and a series of towers that are already going up that you may be familiar with, that have been designed by Handel, and we are then designing these 2 towers, which is known as Block D currently. The master plan calls really for the extension of the streets that otherwise terminate at West Street. So DuPont, Eagle, Freeman, and Green, all to make their way towards the waterfront, and then for the waterfront itself to be redeveloped with a continuous path. Some of that's already taking place just north of our site in the developments that have already happened. And I think we were really excited to participate in this extension of the neighborhood to the waterfront, and also to bring the sense of the waterfront into the architecture that we could create here. This kind of potential for a kind of new activated vista leading you to the water and then also connecting to the rest of the city. When you look at Greenpoint, especially some number of the blocks are actually quite long, especially between Manhattan and Franklin. And of course, depending on which block you're in, you're also faced with kind of relatively long block from West Street to the waterfront. So one of the things that we noticed was that within those long blocks in Greenpoint, there's actually quite a bit of variety given the different scales of buildings and different heights, and even the way the buildings step in and out that makes for a variegated streetscape. That's something we didn't want to necessarily lose, even though we were building a single building. And so when we looked at the ground condition, we wanted to create something not as a straight street wall, but rather using subtle ins and outs and notches to help define different moments or different programmatic sections within the building and create some spatial variety as you move along the street and to denote entries. So here's some kind of early concept sketches for this idea, and you'll see how this played out later when Chris shows a bit about the facade and how we're still trying to utilize kind of subtle ways to break down the length of the facade and kind of make the building legible as you move through it or move around it. When it came to design the towers for the building, we tested kind of a number of different potentials. We were always going to design 2 towers. That's what was allocated within the zoning for the site, a 400-foot tower and a 300-foot tower. And so the whole idea of how to create a set of mutually kind of beneficial twins or kind of fraternal twins, something we were trying to look at in a variety of ways. When we looked at how to respond to the site, one of the things we also attuned to is the idea of view, of course. You have an incredible view of the skyline of Manhattan from any of these sites along the waterfront. But when you look at the actual view itself, of course, directly across from you is the lower area defined by Peter Cooper Village and Stuytown. And so the more dramatic parts of the skyline are more towards Midtown to the north and downtown to the south. And here, just the kind of initial view study showing that. And so we wanted to subtly bias views towards the Midtown views and to downtown views. And also, of course, given the proximity of the towers, to try to set views up in a way where you wouldn't feel that you were just looking into another part of the development. The zoning for the site set up a condition where if we maximize the floor plate size of each tower and adhere to the required setbacks, you would end up with 2 towers that were only 40 feet apart, which we thought was too, not particularly generous and not kind of creating a condition that we wanted to push forward. And so we instead wanted to make something a little bit more like a typical street, so creating at least 60 feet of space between the 2 towers. And then the design really evolved by trying to mediate between the desire for that amount of space, but also maximizing the floor plate size in certain areas of the building. And so the tower that's on the north side, the shorter 300-foot tower, steps out at the base, and the taller tower at 400 feet steps out at the top. That aligned in a way with what was going on around the building. So the northern tower, the shorter one, is directly adjacent to a park. So the lower levels could actually get park frontage, whereas the taller tower has kind of more dramatic city views. And then those 2 forms of, those 2 towers are then shaped to create terraces and a series of overhangs that in a way link the 2 buildings together, almost as though they began as one block, but were then separated into 2. So here you see the resulting form. Essentially, one tower has a set of cascading terraces, and the other a set of set outs or cantilevers, each 24 feet, culminating in a total 48-foot cantilever over the course of the whole tower. We think that it makes a pair of towers that, while distinct, are intimately linked. And again, the tension between them is kind of always present. But they also, in a way, kind of frame a view to the city. The way that the building steps in and out, and also its facade, as Chris will explain later, tries to also mediate the inevitable contrast and scale between these towers and the existing neighborhood around it, which again is kind of dominated by 4, 6, or even 8-story buildings. So we wanted to, in a way, imagine that our tower is made up of multiple modules of the neighborhood itself. And the divisions that are created by the terracing and by the step outs, in a way, break the 2 towers down into modules of either 7 or 8 stories that begin to be more compatible, you could say, with the scale of the buildings in the neighborhood to the east. So here, a view looking down Eagle Street at the east facade of both towers. We also, in a way, wanted to create a set of towers that would have a face that really responded to the neighborhood. Of course, the view is one of the main selling points here, and I think that often results in towers being built here that look like they're looking away from the neighborhood, but we were happy that the more dramatic of the facades actually faced the neighborhood. And here you see the set of 24-foot cantilevers at each corner, kind of flipping back and forth. And here a view from within the courtyard between the 2 towers. This is a section taken through the middle of the tower. We'll talk more about how we're accomplishing this structurally in a minute, but essentially you can see here that it cut straight through the middle because of the way that the form is angling. You have, in every case, a 12-foot cantilever, but it goes down to 0 as you move in one direction and to 24 feet as you go in the other direction. And then here, the 300-foot tower where there's a set of similarly scaled setback terraces facing the water. And that's one of the ways we wanted to, again, bring the waterfront up onto the building with a set of terraces and also that are on the building for residents, but also terraces that are shared by all of the residents together. Here, I'll just quickly go through a set of very schematic plans just to give you a better sense of the way that the geometry of the building works. So again, this is the taller tower here on the left and the shorter tower on the right. And as you move up the building, it gradually steps out one corner at a time or steps back one corner at a time. Because it happens in a series of 7 or 8 story increments, we have kind of repetition between the different volumes, but also variety as you move up the tower. So Chris is actually standing in front of a model of the building. Thanks. And this is that model kind of under construction. Like many offices, we're very interested in model building as a way to explore and further develop the building. And of course, we tend to go up in scale as we move through the project. This was from the end of schematic design. And here you see that same model here. So it gives us a good way to try to really explore the details of how the overall facade is working, how the divisions between these different blocks, for example, and other components of the design. I think one thing that we like about the 2 buildings is that from some vantage points, they look very normal, you could say, very simple and not trying too hard. But from other vantage points, largely in the way that they come together, there's something dramatic. So with that, I'll turn it over to Chris.
Yeah, hi everyone. So just a bit about the program. Of course, it's might have been obvious by now, but it's mostly residential. We have about 860,000 square feet of GFA, and it's about 750 apartments, 30% of which are affordable at various income tiers. So that amounts to about 224 units. There's a healthy amenity program and some ground floor commercial space. And then, of course, the public space that Jason mentioned is part of the contribution to the overall master plan for the waterfront Esplanade, which is done by James Corner Field Operations. So here you can see how the program lays out in the building. Again, mostly rental with some sort of higher end penthouses on the upper floors of both towers. And then you can also start to see where the commercial is lining on Eagle and West Street with a little bit facing the park on DuPont. And then for the amenity package, this is kind of looking as if you're floating above the river. You can see everything is sort of facing the western side to take advantage of the views from all of these various amenities. So we have a second floor terrace, a fourth floor terrace with a pool, an indoor lap pool, and some other health or fitness oriented programs in the bridge that connect the two towers. And then a few more sort of recreational or kind of productivity related amenities in the base of D1, which is the taller tower. So here, just a close-up of the model behind me, but showing how these sort of, how the bridge really ties in the podium and the two towers together and links all of the residents through these different kind of programs with the shared amenity spaces. And here you get a section through that, and you can see how the bridge is sort of spanning over the podium, and the terrace in the center is a kind of covered portion of the second floor terrace where we have a children's play area and some sort of reading nooks where you can get a little bit of shade from the sun. And an early concept view of what the pool, the view from the lap pool inside of the bridge would look like, of course with amazing views from almost any height on the site. And then this is a view from the fourth floor, what's now the outdoor pool terrace. So one of the things that we had to contend with pretty early on was the fact that we had designed a 48-foot cantilever tower and that all of its weight wanted to land right in the middle of our bridge. So you end up with 4 mega columns that are carrying essentially 400 feet of building over the eastern side of the building that are coming down straight in our lobby and our kind of amenity spaces. So we worked with DeSimone pretty closely through a number of different studies and tried to reconfigure the columns to see if we could make it work. But eventually, DeSimone came up with the idea of splitting the columns that land in the lobby actually in the bridge spaces above, creating kind of an architectural or structural moment in these amenity spaces within the bridge, and allowing the lobby to be a triple height, fully clear and free space with no structure inside. So here you get a view of this, what we're calling the reservable room or kind of lounge space in the southern end of the bridge. And then now you can see the lobby is, again, column free. So what we would have had before as you entered the lobby and sort of clearer view of that, bit more expansive and ability to see out to the various terraces looking west. And so at this stage, we used VR to create a few images to try and help convey some of these design moves we had made, both this kind of stepping garden and adjacent to the lobby, and then also kind of how you would experience these various terraces and how you would be able to take advantage of these views from these kind of different program areas that would be common to the residents. So again, at most heights, I think even if you're standing on the ground floor, actually, the views are really unobstructed because of our adjacency to the river. So it's really not about how tall you have to get to see the skyline, but how you can kind of maximize the amount of opportunities to take advantage of the view. And here you can get a sense of what it'd be like to live on this terrace on the 7th floor and see the cantilevers above you. And then finally, there's a view from inside one of the apartments in D2, which is the 300-foot tower. And again, it's kind of all about the views and also kind of a nice view of your neighboring building, the D1 tower. For facade, which you might have seen a bit of in the VR, we've started to look around the context, and as Jason indicated, we've been looking at both the scale and kind of the character of the neighborhood, and all of the residential townhouses, for the most part, have a series of varying shingles. Some have a variety of different kind of scales of shingles to create different patterns on these smaller buildings, and even looking at some art references to see how a simple pattern just kind of oriented in different ways can create quite distinctive sort of graphic moments. And so we mocked up a few, playing around with both scale and orientation. This is all in blue foam. And what we liked about this direction is that you can use the same material and essentially the same profile, but rotate it in a number of different orientations, and it will actually behave quite differently when exposed to the moving sun and also just around the different tiers of the towers. So using those different orientations to further distinguish each kind of tier of the towers so that they would appear subtly different depending on how the shadow was kind of landing between the shingles. We also did a number of studies to make sure compositionally that it did provide that sort of distinctive shadow play. And here you can see an early view of us testing out the shingles at kind of a division where one block meets the next. And another thing that we worked very hard to preserve was as large of punched windows as possible, because of course the views are the biggest selling point for the project. So these are 8-foot by 8-foot punched windows, which from the outside may not seem so generous, but actually from inside they're quite expansive. And then we continued to mock up the shingles in-house to test both how the windows would interact with them and also start looking at materials. And then for the podium, it's almost like taking that strategy and moving it horizontally and wanting to take the notches that you mentioned early on to break down the street wall and to create some kind of distinctive moments. So the shingles go all the way down to the ground, but there are different orientations around the podium. And we thought if we could merge the two orientations that meet at these notches, you can create something new without kind of veering too far from the original intent of the facade. So here's what we call the fish scale, which is essentially a vertical and a diagonal merged shingle meeting. And you can see that mock-up actually here behind me. And so using that sort of texture to really indicate where two kind of parts of the building are meeting and to create distinctive moments at entries and lobbies around the project. So again, working hard in our model shop to create some in-house tests to make sure that, you know, we actually like it. And then testing it out at the D1 lobby, which is one of the bigger moments where we have this fish scale wall. And then as we developed the facade even further, we're working with BPDL out of Quebec, and they gave us a sort of range of palettes, I guess, of materials that we could use within the concrete itself. So we tested a number of different colors of cement and aggregate and sand, and then we tested them into shingles, and we came up with a couple that we liked. We tested them again on site and actually got to see how the sun moved around them and ended up landing on a favorite. Oh, what happened? Sorry, I just exited out. Okay, all right. And then, you know, again, we were saying that there's a kind of play of light and shadow with these shingles, so we wanted to test that both in renderings and also in real life. So when we got to the visual mock-up last summer, we were able to get it oriented due south and do a 24-hour time lapse of it. And we were happy to see that it was actually very graphic how the shadow plays with the shingles. And that will obviously change depending on the time of day, where the shingles are oriented on the project, facing north, south, or east or west. And and also their kind of geometric orientation. So just some images of us on site, and the kind of funny thing was that 11 Hoyt, which is a studio gang project, was being constructed at the same time by BPDL. So our mock-ups would arrive on the same trailer as the Genie Gang mock-ups. So we got to kind of take a look at what they were doing over there at 11 Hoyt at the same time. And a number of kind of material studies while we were on site. And a lot of kind of detailed looks at how to finish these mega panels, particularly at corners, and how to get these sort of geometries, which in a horizontal shingle turns a corner quite well. Same with the verticals, but at the diagonal, you start to question how do they actually wrap around, and how do you actually pull this piece of concrete out of the mold. So working through this with BPDL to understand what kind of the best solution would be. And in our case, it was to square off the corner so you could actually remove these from molds and also kind of reduce the number of pointy edges that were hanging at each of the corners. And we got to see that in person earlier this year before the shelter in place started. So this is at a UL facility in Montreal where we got to see the full-size PMU. And I'm going to hand it off to Allan and Louis again to talk a bit about the structural design and how the whole thing is standing up. Allan, do you have control?
So, Allan, you're on mute. You know, here we're going to share a couple of images here about, you know, the structure and, you know, some rather dramatic and inspirational images that kind of really show the structural challenges, you know, that we had to address. Allan, if you can jump to the next slide here. So, you know, I think when you know, we thought when you look at this, that there were, you know, that it's rather, you know, there's some obvious, I guess, solutions towards answering, or excuse me, towards addressing gravity, lateral, and you know, wind and seismic. But what's more challenging is finding solutions that that one, respond to the architectural program and to what the ultimate goal was from the ownership side, which is you know, delivering this unique project in an efficient and economical manner. You know, so we were challenged with finding structural solutions that that didn't impact the architecture, the floor-to-floor height, and would be relatively easily constructible by a number of different contractors. So Allan's going to run you through some of the different iterations that we went through for both the D1 and D2 towers.
Hi, everyone. So this is, we'll start with the smaller tower, which is an 8-story structure here. We call this D3, and this is really the mechanical, electrical, and plumbing kind of heart of the project. It's approximately 100 feet tall, conventional reinforced concrete construction, 8-inch slabs, regular cast-in-place concrete shear walls. What's unique about this is the interface at the D1 side on the left. You can see it kind of jogs around the mega columns, and that was due to the D1 columns being pushed out of the lobby, as Chris said, to clear the space, and that was really pushed into the D3 space there. We jogged that interface. So this building was mostly conventional, and the challenges were related to coordination with the MEP systems, the generator, the associated ductwork and conduits from the other 2 buildings. You can see here the highlighted systems were being brought in from the other towers. On the 2nd floor in the courtyard there, we had to design a dual mechanical well, which was exhaust for all the air in the subgrade parking spaces. And the generator capable of serving the project is on the roof there. This is the D2 tower. It's approximately 350 feet tall. It's got 5 setback roofs, 4 of them on the east side. We used localized transfer slabs to really optimize the architectural column layout. And at the 7th floor, which is the lowest setback you see there, the thickness of the transfer slab would have conflicted with the floor-to-floor height. So we drove those columns through. So you'll see on the next slide here, we highlighted the transfer slabs in red. And the challenge with this tower was when you have transfer columns supporting other transfer slabs, you really have to sum the deflections and make sure that the deflections are being carry through the height of the building, so you don't have any issues of excessive deflection. Now, the D1 tower obviously was the largest challenge structurally. It's about 450 feet tall, and it's really composed of 7-story blocks stacked with this staggered configuration. So the next 2 slides will show kind of the studies we went through to address the gravity system. The first thought for the cantilever system was obviously a truss. And at these loads, we required a full-story truss, which could either be steel, as we have shown here on the left, or it could be a full-height concrete wall. Obviously, these really delineate and limit the space architecturally. So this is kind of a no-go from that standpoint. The next studies we looked at were 2 sloped column studies. The first one being a low angle, meaning an aggressive slope, 45 degrees. It really minimizes the effect of the slope columns on the architectural layout by limiting the number of floors affected. But kind of the drawback for that would be the horizontal loads from such an aggressive slope really required structural depth at the top and the bottom of the slope columns. You kind of see it highlighted in red here. Those tieback and compression struts would address the horizontal compression and tension forces from the slope columns. So we're getting closer to a structural system that works architecturally. Now, the system that we ultimately ended up using was the high angle slope column system. High angle meaning a gradual slope. More floors were affected, but to a lesser degree because the slope is quite gradual when they're sloping 3 to 7 floors. So more floors are affected, smaller architectural impact, and it has an added benefit of reducing horizontal forces. So those forces were resolvable within the thickness of the slab. That's a big plus because you don't need the soffits, and it really frees up the space architecturally. These 4 images on the left here are elevation views cutting through the building looking north. And so it really shows the sloped columns and the hangers below them that support the floors below the slope columns. And what happens to those slope columns when it hits the lobby. You see on the 2 elevations on the right, they slope out to clear the lobby, and we'll see that in future slides. Now that we kind of established the gravity system, we have to look at the foundation system. So we started with the geotechnical investigation. On the left is the subsurface stratigraphy, which shows that the site consists of a layer of uncontrolled urban fill, which is pretty standard here in New York. Then you have river sediment deposits. Then you have layers of medium dense to dense sand. And then you have decomposed rock, and finally bedrock. Bedrock was around 30 feet to 110 feet in elevation. This site was classified site class B, and liquefaction was a concern due to the sandy layers. So we performed a site-specific seismic study, and we got a design category of B, which is good news. The geotechnical engineer, which was Langen, recommended deep foundations, which makes sense for a project of this height. And we ended up using open-ended pipe piles and drilled mini caisson rock sockets for tension. The groundwater here was observed at +1 to +2 feet, since we're near the river here. Now, to continue our studies of the gravity systems, we looked at first the baseline foundation study, which is the as of right building. It wouldn't have the cantilevered step outs, and that gave us an idea for a reference for the number of piles required for this project. Then we looked at the transfer element, which was the cantilever truss system, and that resulted in a 12% increase in the number of piles. You see 395 piles compared to the 352 baseline. So that's a significant increase in the number of piles. And here we confirmed that the slope columns gave us a 5% increase in the number of piles because the slope columns gave us a horizontal kick that can be resolved by the lateral system, which is that can be resolved in a larger area, spread out more to more piles. So, and the transfer elements, they magnify vertical forces, and they really concentrate the loads on the 4 megacolumns you see on the right, in the bottom right there. Those 4 megacolumns are see much higher vertical forces due to the mechanical lever principle of a cantilever truss. So this study confirms that the slope columns would be an economic choice for foundations as well. Here we have our 3D model of our foundation system. We are in a flood zone, so we are full dry flood proof here, full bathtub. We have a 16-inch pressure slab, and the pile systems are pile caps at the columns and a pile mat at the shear walls. The base flood elevation here is 12 feet, and the majority of the ground floor is at 16'10", which is basically 75% of the ground floor. On the right side, which is the east in this image, there are some lower retail spaces which requires temporary flood barriers. Now that we have the gravity system kind of locked down, we started looking at the lateral system. Now, one major component for the D1 project would be the building lean. This building experiences an overturn moment due to gravity forces, as well as the typical lateral wind and seismic loads. So here we see that under gravity load and the asymmetrical nature of the gravity and lateral systems, the building sees a slight planned clockwise rotation, in addition to the deflection in the east-west direction. That rotation is kind of minor compared to the horizontal movement. So you'll see how we address this movement during construction in the next slides. One important thing to note here was that we performed a construction sequence analysis to see how the building moves during construction. So that'll be important because we're going to try to correct this movement, and you need to see how the building moves as you build it. Construction sequence analysis really has to do with how we expect the building to be constructed, which would be in the 7-story blocks that we have. And here in the next slide, in the top left, we see the vertical movement of the building. So that red line indicates a proposed construction location. We're going to pre-camber the building towards the river, which is westward. The dotted black line on the right indicates anticipated eastward movement. And when you put the two of them together, it should put us much closer to the design vertical location, which is what we're going to verify using survey information during the lifetime of construction. The key plan on the right, in the top right there, shows 5 points, 4 in the corners, 1 in the middle near the shear walls, where we're going to give construction survey locations. Now, how you use this chart is where you survey are the floors on the left, and the construction level where you're constructed to is on the row on the top. So when you're at a certain level, you survey. So in the bottom left, level 7, when you're surveying that level, you've built up to level 21. you should see a 0.05 inch X movement. So this will really give the live confirmation during construction of how the building's moving, how we're anticipating it to move, and how to correct that movement as we build. Now the slope columns have to be supplemented with hangers to hang the floors below the slope columns. We reviewed concrete and steel options for this and ultimately went with concrete hangers for the aesthetics and to maintain a faster construction schedule, just so we can have one trade, a concrete trade, rather than try to coordinate that on kind of an expedited construction schedule. These hangers are concrete and they will be post-tensioned to around 150,000 pounds to 300,000 pounds force. So the idea here is to, the bottom left, the image will show how the formwork, the temporary shoring platform, will allow this construction to proceed. So the cantilever platforms are built, these smaller platforms are built below the main cantilever floor. So the main cantilever floor is level 14. So you start at level 11 with smaller cantilevers, and these two smaller cantilever platforms are only to assist in the erection of the main cantilever platform. Now, once that main cantilever platform is constructed, it will allow normal construction sequencing to proceed above it. So very important here is how this cantilever system performs so that you don't compound the movement of the building with temporary shoring deflections as well. Here we have some details of the post-tension hanger columns. On the right is showing the sequence from with the grout vents. They'll be grouted from below with intermittent grout tubes to ensure proper grouting. This is the fully bonded system. The middle is our design drawing indicating that the hangers are extended 1 story above the slope columns so that you avoid the rebar congestion. So when we stress from the top here, we can pull without interference. On the left is details regarding the post-tension system with the grout sleeve here and the live and dead anchorages. Here we call these the AFrames. This is where the mega columns from all the cantilever slope columns, they kind of converge, and above the lobby, they A-frame and they split out to either side of the lobby. And these slope columns have a significant load in them. They have around almost 1.5 million to 2.5 million pounds going through them. And this is another source for deflection kind of in the building. So we are post-tensioning the horizontal beam at the base of the A-frames to address that, to limit that movement. So those poles will be staged because of the high load in those elements. This slide shows the geometry of these A-frames, and they're not very entirely symmetrical, just based on the geometry. And the bottom shows post-tensioning details. You see multi-strand system here that will be grouted and fully grouted as well. Now with the stage stressing, here on the next slide, we're staging it in 3 stages. So they will pull to 33%, construct to the 30th floor, pull to 66% and construct to the 36th floor, and then pull the final amount to allow the building to top out. Now you'll see that the first stage is very large because the main portion of the building, what's contributing to the overturn, is largely in the higher floors here. So the contribution is weighted much higher towards the top. Here we see the Amenity Bridge, which was a main structural challenge. It's composed of steel trusses with no vertical elements. And the actual bridge itself spans about approximately 60 to 75 feet. So it's not really a large structural span, but the truss does continue to aesthetically continue the truss system out over the rest of the building here. So those truss elements are serving as gravity elements, but it visually looks like the truss is spanning the full length of the project. And now we're going to show a cross section through this bridge. This Amenity Bridge level has 3 levels. The top and bottom are your standard slab of metal deck construction with steel framing. And what's interesting about this bridge is the middle level contains a full-length pool. And to achieve the drop ceiling below the pool and kind of minimize the structural footprint at the facade, what you see of the structural floor construction really has to be minimized. So we developed a double bent beam system, and people call it different things. People are calling it the double dog leg, pork chop for some reason. I don't know what that means, but it's kind of an interesting looking structural beam to support the pool while allowing the mechanical, electrical, and plumbing systems to run in that interstitial space there. So I think that's basically all I have time for. So I'm gonna hand it back to Chris here.
Yeah, thanks, Allan. So we had, obviously, we've talked a bit more. We had some slides to show some of the sort of technical aspects and how we ended up into construction October of last year. Of course, there was a hiatus on construction, but we were allowed to move forward for the most part due to the 30% affordable content. So through shelter in place, we're still looking at samples and getting VE'd and getting substitutions, and just wanted to end with a few shots of the foundations and then this kind of earth cam time lapse we have where you can see the piles going in, and then you start to see the outline of the foundations and the pile caps and the pile mats. And towards the end, as we get closer to the summer, you start to see the ground floor come in and even the columns coming up above grade. So right now, I think the 3rd floor has been poured for the podium portion of the project, and we're hoping to have facade mega panels arrive on site sometime towards the end of this year. So be on the lookout. We should be topping out sometime early 2021.
Great. Thanks, everyone. This was quite, I'm sure I speak to everyone that watched, this quite an impressive project. And the extent and detail with which you explained it was amazing. So really appreciate that. We're a little over in time, but we have a few questions that I think might be generally quite quick. So I'll pose them to the group here and see if you guys can give a quick response. So someone mentioned, are the amenity spaces available to both affordable unit tenants and market unit tenants? Chris or Jason?
Yeah, I can respond to that. The some amenities will be available to all of the residents, and some will be part of a paid-for program. So that will be open to residents, but it will be coming at some monthly fee.
Okay. And the next one down, someone asked, I see a growing number of residential projects with large overhangs, specifically in New York. This is kind of becoming a thing for sure. They're wondering what it means to the residents who live in the units under those cantilevers. The sunlight and the view to the sky would be limited. What considerations are given to those residents? Maybe in your case, the residents are a part of your same block, so maybe it's not a big issue.
Well, so all of our units that are at the ends of the cantilever also have windows facing on the long faces, but facing both north and south. And so there's not a room that relies solely on spaces directly underneath the cantilevers for light and air. Right. So trying to, of course, keep that in consideration for just general psychology of living directly under the soffit. Maybe some people like that, but you still want to have access to unobstructed sunlight and air.
Yeah, I think it's one of the things about a building of this scale that you can have variety, and that variety is actually even a positive. And one of the benefits too of the way that the cantilever tapers back towards, you know, the way the facade angles means that the impact of the overhang is also diminishes as you run along the facade. So, and paying close attention to how the units get planned and not making someone's living room only have access to the window directly under the cantilever, as Chris said.
Sure, so maybe it's more of an issue for buildings in the city that see building, you know, directly on top of the adjacent building. One other question that I also had as well that also popped up in the chat is, what sort of green building measures did you guys take for the building? With local law 97, did you have to consider any future green initiatives, sustainability initiatives? Was that an issue? How did you deal with it?
There were a number of sort of required initiatives, and then of course optional ones. And the project, I believe, is close to a LEED Silver rating, but I'm not making any promises just yet. We're too early on to make sure that we get that. But the original target was just to achieve a LEED kind of standard rating. But through some of the measures we got through, we're hoping to get to LEED Silver. One sort of interesting thing that came up in early construction was this, the National gas pipeline that was supposed to come from New Jersey, and it was supposed to be expanded, and it was actually going to prevent us from being able to have access to natural gas for the project because of the time of construction. And the alternative was to essentially go to oil fuel for generators and to go fully electric on all the other sort of boiling and hot water systems, which arguably could be more sustainable if you can implement more sustainable electrical fuel sources, but ultimately the oil fuel burning for the generator also seemed pretty problematic. In the end, we ended up going partially electric, and we're able to actually get natural gas to supply the larger systems, the heating systems on the project. But as far as like major sustainability initiatives, the project is about, has a very tight mega panel kind of insulated envelope with a pretty heavy duty glass assembly. So just focusing on the facade and the terraces to achieve the kind of as high rating as we could, even with a 45% transparency on the facade.
Great, that makes a lot of sense. Maybe take one more question here. From Elliot, question regarding GFRC as a lightweight alternative to precast. Did you guys look into that at all?
We did a little bit. It's obviously lighter weight and can be formed into much more like kind of intricate textures than, say, concrete. But the prefabrication or the unitization of GFRC is also a very different beast than precast mega panels, which are inherently their own structure, as opposed to GFRC, which would need some sort of substrate and assembly to create what's ultimately a unitized system versus just relying on a single kind of mono material panel that is self-supporting. We also kind of prefer the raw and maybe kind of honest texture of concrete for this particular project. And the finish that we ended up with is actually a pretty aggressive sandblast on the concrete. So you get a sense of the texture and the sand and the aggregate, trying to expose kind of natural materials within it, which is a bit harder to create in something like GFRC. But we did look at it very early on.
Okay, I see. Yeah, I'm excited to see the shingling patterns and the shading that you get on that building. I think it's going to be very nice. Okay, well, thank you, everyone. I don't think we're a little over time, so I want to be conscious of people's time commitments as we are in the middle of the day, lunchtime, so to speak. So for a last send off, I just want to say thanks again from the New York chapter and everyone in New York and abroad that are watching, as well as all of our new friends from OMA and DeSimone that shared this time with us. So if you're interested in future webinars, please follow CTBUH either on the website or through social media, and we'll be having more of these discussions in the future. So thanks everyone, and have a good day. Bye.
Thanks everyone.